That looks kind of sad. Poor Kate Winslet. Oh my god, just standing there alone with no jack. Netflix just released a very interesting open source AI tool called Video Object and Interaction Deletion, or VOID. So most AI video tools are already great at erasing objects, that's nothing new, but they are terrible at erasing the consequences of those objects in the scene. So for example, if you're removing a bowling ball hitting pins, most models leave the pins falling over for no reason. But Void tries to fix this issue. It's a new framework from Netflix and Insight that understands cause and effect and modifies the video content based on the removed objects. So in this video, we'll take a closer look at this model, see how it works, and I actually built a web app to test this model in all of its glory, so we'll do a few video tests on our own. It's gonna be a lot of fun, so let's dive into it. So VOID stands for Video Object and Interaction Deletion. To understand why this is such a big deal, you have to look at how video inpainting usually works. So standard AI erasers are basically content-aware fill on steroids. They look at the pixels around the hole and try to guess what should be there. This works for a watermark or a person standing still, but it falls apart the moment there is a physical interaction. If you remove a girl making a smoothie in a blender, a normal AI will erase the person, but it will leave the blender spinning and churning for no reason. It fixes the appearance, but it ignores the physics of other objects around it. Void is designed to solve that ghost interaction problem by reimagining a counterfactual reality, basically a version of the video where that object or person never existed in the first place. And the way it pulls this off is actually pretty clever. It doesn't just start painting immediately. Instead, it uses a two-pass system. In the first step, they do a reasoning phase. First, Void uses a vision language model and SAM2, or Segment Anything Model 2, to look at the scene. I actually did a whole separate video on how SAM2 works, so check that out if you're interested. So while SAM2 creates a pixel-perfect track of the object you want to remove, the AI asks itself the question, if I remove this, what else changes? If you remove one domino from a stack of dominoes, the AI identifies that other dominoes are casually affected. It then creates what the researchers call a quad mask, a specific map that tells the diffusion model not just where to erase, but where to rewrite the physics of the surrounding area. And then step 2 is the generation and refinement. Once it has generated that map, a video diffusion model generates the new footage. Now, sometimes these models can be a bit dreamy, like objects might morph or lose their shape. So to fix this, Void has an optional second pass. It uses something called flow warp noise to lock those shapes into place, making sure that while the physics change, the remaining objects stay solid and consistent. But you might be wondering, how do you teach an AI what didn't happen? So the team at Netflix and Insight couldn't just film a car crash and then uncrash it in real life to get the training data. Instead, they used synthetic environments like Kubrick. They ran thousands of physics simulations where they had a before and an after version. One version with a collision and one version where the object was never there. By showing AI both versions, it learned the relationship between an object's presence and its impact on the environment. So all of that sounds super fascinating, but let's actually test out this tool for ourselves. So the best way to run it would be to use a cloud GPU like a RunPod module running on an H100 GPU or something equivalent. But I'm gonna tell you right off the bat, setting it up is not straightforward at all. The GitHub documentation has a lot of holes and misleading information, so to get it working correctly, there are a few things you have to watch out for. For example, this command will likely fail because they never specified that you need the SAM3 model for this procedure. And this command might fail because they never specified that quad masks must be strictly named quadmask_0.mp4 to work properly. So there are a lot of these little issues that are not documented here, and their Gradio demo is nice if you already have a mask segmented with SAM2, but they don't provide the graphical user interface to actually create that mask. So what I did is I built a custom web app that fixes all these issues and provides you with a ready-to-use UI that goes through the segmentation step, the inference step, and even the two-pass system, so you can just upload your video, segment the mask, and render out the final output. And that's exactly what we're gonna do now. So first, you have to spin up a RunPod instance with a beefy GPU. I'm gonna be using an H100 for this test. And in the template section, make sure you increase the container size to 100 gigabytes. And in the port section, add the port 8998, because this is where we will be exposing our web app. Then all you have to do is SSH into the pod, clone my repo, cd into it, and run the run.sh command. And it will also ask you to provide a Hugging Face token so you can actually download the models. And also make sure you have access to the SAM3 repository, because this is a gated model and you need to request permission to use it. But usually the process is pretty quick and you get approved in a few minutes. And then you will also need a Gemini API key, because in the segmentation step, the model uses Gemini to determine pose estimation for a precise quad mask generation. All right, and if you have both of those credentials, then let the run.sh command install everything. And once that is done, we can now launch the web app with the following command outlined here. And now on the RunPod page, you have to click on this port, and that will open up our web app. And now we can finally start testing the model. So for my first test, I will use this famous scene from The Matrix, and I will try to remove Neo from the scene and see what happens. So the very first thing you have to do is specify the removal instruction prompt. In this case, we can specify something like remove the fighter in the white kimono from the scene. And after that, we get to the section where you just segment a bunch of points around the object or person you want to remove, so that the SAM2 model knows which shape to focus on. And then specify the output folder where we will store our result files. And you have to remember the name of this folder, because this will be the unique identifier that we will be using in other tabs to identify which video we are working with. After that, we can proceed to the second tab, which will run our segmentation step and run the process. And once that is done, we can move to tab 3, which is the inference step, which is where the model will actually try to remove the desired object or person. And here we need to type in that folder name again. And here we need to specify a prompt that describes what the video should look like without the existence of our removed object or person. So in our case, that would be something like a fighter in a dark kimono standing inside a gym. And they also recommend not mentioning the removed object or person, just focusing on what needs to be in the video, and run the inference step. And once that is done, we can now head to the results tab and see our final video. And once again, we need to specify the video folder, and there you go. Look at that. Yeah, it looks like Morpheus is fighting a ghost. We can see that there are some inconsistencies with the removal of the hands and other things, so it's not perfect, but there's another thing we can do to try to improve it. We can now run it through the second pass filter, which is tab 4, to try to achieve better results. And so after running the second pass, we now get this additional window where we see the result of the second pass. And once again, it still looks kind of weird. It still feels like Morpheus is fighting a ghost or dancing or something. So as you can see, it does not work for every scene. Some scenes are just going to be very weird. But it does do a good job of removing Neo from the scene completely. That being said, let's try 2 more fun examples. So here is the famous dancing scene from La La Land. And here I'm going to try to remove Emma Stone from the scene and see what happens. Wow, look at that. This looks almost flawless. I can really believe that Ryan Gosling is just dancing by himself here. And you see the moment where Emma Stone goes in front of Ryan Gosling? This transition is almost seamless. We can see some minor artifacts, but for the most part, wow, this is a stunning result. So from all of the results I tested, this one was the best. And for some reason, I thought this is going to be the hardest example to run. But surprisingly, this yielded the best results from all the tests I did. All right, I want to try one more example. In this one, I want to try to remove Leonardo DiCaprio from the famous Titanic scene and see what happens. Oh, wow. That looks kind of sad. Poor Kate Winslet. Oh my God, just standing there alone with no Jack. That looks interesting. We can see that this model did a great job of removing Leo from the scene, although we can see some leftover artifacts on Kate Winslet's arm. And oh my god, this is so creepy. There is still a creepy leftover hand holding Kate's arm on the other side. Oh no, I can't unsee it now. Honestly, this is my bad because I did not segment those specific points for removal in the segmentation step, so that's on me. And we also see that Kate Winslet's face morphs a bit, so there's a bit of uncanny valley going on here for sure. So overall, I think this tool does what it advertises. It's just a matter of the specific video and the nature of it. Obviously, we can't force Morpheus to be standing still in this scene, but if we look at some other examples on their project page, they are absolutely incredible. So I think this model does have some solid capabilities, and maybe with extra training, it might get even better. So there you have it, folks. That is the Void model in a nutshell. Honestly, I had so much fun testing this. And since it's developed by Netflix, I'm actually super curious to know what will they be using this for. Could it be used to alter some video narratives based on user preferences or choices? Similarly how Netflix added that choose your own adventure type of interactive experience on the Black Mirror Bandersnatch show. You remember that? Who knows? But in any case, it's going to be very interesting to see how the use of this tool evolves going forward. But what do you think about this framework? What kind of use cases would this tool be useful for? Let us know your thoughts in the comment section down below. And folks, if you like these types of technical breakdowns, please let me know by smashing that like button underneath the video, and also don't forget to subscribe to our channel. This has been Andres from BetterStack, and I will see you in the next videos.